Welcome to How to Succeed in ECE Without Really Trying. I'm Dr. Linda DeBrunner, and in this video I will be talking about how to use feedback with amplifiers. We want to make sure that we can control our amplifiers so that they can remain stable. And the ideal amplifier that we talked about before is actually called an open loop amplifier. It doesn't have any feedback. We can define a circuit to be open loop if there's no path from the output on the right side of our picture to the input, okay? No path from the output to the input. If you want to, you can add feedback that would allow you to have output from the output feeding back into the input of the amplifier, or you could take the input and feed it forward to the output. So that would be feedback or feed forward systems. There are reasons you might want to have a feed forward system, but we will only consider feedback systems where we can make stable circuits and have a good bandwidth. Okay. So to achieve feedback in an amplifier, what we want to do is create a circuit branch or more than one branch that connects both sides of the amplifier. There are two different possibilities here, and both can be used in practice. Positive feedback will tend to reinforce the amplifier input, and negative feedback, which tends to inhibit the amplifier input. There are reasons you might want to use positive feedback, but negative feedback is much more common, mostly because it has good stability, and you can get a large gain A that will give a gain of G over a large range of frequencies. Okay, G will be much smaller than A, but it will still be a gain that's desirable across a large range of frequencies. So here's a block diagram of a circuit showing negative feedback. We have an input X of t, we have an output Y of t, okay? And this is going to be negative feedback because we have a minus sign on that summing element that's marked with a plus. So what we're going to do is X of t comes in, we add to it some beta times Y of t, that's a negative beta times Y of t, that's the negative feedback, to get some error value E of t. That then goes through the amplifier to give Y of t, and then that Y of t is fed back again. So we have this feedback system. We can write Y of t as a function of E of t, right? So Y of t will be A times E of t. And then E of t is defined to be X of t minus beta Y of t. If we put these two together, we can evaluate the circuit and we end up with Y is equal to AE, and then plug in for E, so you'll have X minus beta Y, and then multiply through by the A, move the beta AY to the left side, and we get Y plus beta AY is equal to A times X, and then we can solve for Y over X, which we define to be G, and that will be A over 1 plus beta A. And so that will be the gain. A little bit of jargon that we might want to know. Okay, the loop gain is beta times A, and that's just called the loop gain. Beta is called the feedback gain. And in the diagram above, we have, again, negative feedback because we have that minus term on the summing junction. If we had had a positive there, so we were adding beta A, it would be positive feedback. Things to notice. G will definitely be less than A because beta A is positive, okay? If beta A becomes large, then what we end up with is G will be approximately A over beta A, right? So let's go back for a moment. We have G is equal to A over 1 plus beta A. So if beta A is large, that 1 in the denominator doesn't matter, and we just end up with A over beta A. So G will be approximately A over beta A. Canceling out the A's, we end up with 1 over beta. And that's a really good result. That means that our gain does not depend on the gain of the amplifier, A. Okay. We can similarly write beta Y over X is equal to y over x times beta y over y, just manipulating things here. And that gives us a over 1 plus beta a, that's y over x, times beta. So we'll get beta a over 1 plus beta a. Okay. And that means that beta y over x is approximately equal to 1. And as beta y goes towards x, beta y will go toward x as a becomes large. So in this way, we have used negative feedback to create a practical amplifier.